Hi everyone. Welcome to Man in the Middle Made Easy. Today we're going to be talking to you about the subterfuge attack framework. First we're going to go into a little bit about what each of us did in this project. My name's Chris Shields and I worked on a lot of the ARP attack tools and just the custom attack tools. A good chunk of my work was actually done debugging and ensuring that our new tool actually worked effectively against as many devices as possible. Besides that, I wrote my tools in Python and was often integrating Linux operating system command output using regexes back into our tool. Other than that, I kind of did the project management side of the house. So in terms of the direction, the priorities for the project, and just Google Code site updating the issues and making sure that our latest ideas were up there.
Right, so I'm Matt Toussaint. I did a little bit of the interface design and development. So you have me to blame for all the interface problems you're going to have. It's also a web front end, so I did a lot of work on making sure we had browser compatibility, making sure it worked well on both Firefox, Google Chrome, Safari. And I'm sorry for all you Internet Explorer users out there, but you're on your own. I'm also to blame for all of the framework development, so all the pulling things together and making it something that's extensible, really easy to use, and really easy to put different places. Right, so this is a quick overview of what we're going to talk about. I know a lot of you already know man in the middle attacks, especially ARP cache poisoning, which we're going to focus on a little bit. We're just going to do a really brief overview. So for those of you who don't know, we can fill in the blanks. For those of you who do know, maybe a little bit of a refresher. Then we're going to get started on the framework. We're actually going to talk a little bit about how subterfuge splits off a man in the middle attack into two big different parts. A little bit of a dichotomy of the attack. The getting man in the middle portion, and then the actually leveraging that position to do something worthwhile. And subterfuge extracts those. Then we're going to do a little bit of demonstration, jump right in, give a little example of how it works, how easy it is to use it, and then we're also going to talk a little about countermeasures. So now that you know how dangerous the network is and how easy it is for really anybody to do it, a little couple ways to look out, to know when you're being exploited, and to keep yourself from being owned. Then we're going to talk a little bit about future work, just because subterfuge is still a live project. It's still in beta right now, and where we're going to extend it in the future and what it's going to really become.
So before we go into the talk about the basic man in the middle attack process, we just want you to keep in mind that we are talking about ARPing and not LARPing.
Lightning bolt! Lightning bolt! Lightning bolt! Lightning bolt! Sleep! Lightning bolt! Lightning bolt! Sleep! Lightning bolt!
So anyway, here we have the anatomy of the attack. This is a basic network poison diagram, and so the clients on the right hand side, they're the users, soon to be victims. They're sitting there, they're doing whatever they're doing on the network, and in comes an attacker. He happens to be using subterfuge. Now as soon as he activates subterfuge, using the ARP vulnerability that we're going to talk about, it pretty much gets on the network and it tells all of the different devices, hey, I'm the router, so you can send all of your stuff to me now. And due to the inherently trusting nature of the ARP protocol, everyone says, sure, okay, why not? You're a good guy, right? And so that's where the problem all starts. And so once you have that man in the middle position, when everyone says, okay, I'm going to route the traffic through you, when you're in that spot, there's a multitude of different attacks that you can do. You can sit and monitor traffic, you can see credentials as they're going through, you can actually modify and slap on some extra funness on their information as it's going from the actual legitimate source to the end user. Or you can just add some fun little exploits in their web page, which actually owns their boxes and gives you back shells. So as you can see, it's a pretty devastating position to be in. And this is the vulnerability which has been out there for quite a long time now. We're going to go kind of high speed at this because it's not a new attack and we don't want to bore anyone who really knows about ARP. But This is an example of a poison packet that Subterfuge sends out. So at the top arrow where it says broadcast, it's being sent to the broadcast MAC address. So that's just saying every single device on the network is going to receive this packet. Then below that is the attacker's MAC address. Now below in the address resolution protocol, the ARP reply area, you can see that the router's IP address is actually spoofed in here. So this is where the magic is. This packet's going to go out and say, hey, I'm really from the router, but this is my MAC address. So it actually updates all of the ARP tables on the victim's client machines and says that the attacking machine is now the router.
So the problem is when ARP goes to the broadcast, everybody on there, so all the computers connected to the network are going to see that packet and go, oh, this is for me, it's an ARP packet, and it says, hey, here's the MAC address of the router. And since I want internet, I'm going to go ahead and update my table so that I can continue to have internet. The problem is that there's really no accountability, and we just automatically trust ARP, which, you know, as we all know, is not necessarily a good thing to do with anything. Right, so moving on. As you can see here, we've got a Windows 7 machine just displaying its ARP tables, and we've got the same MAC address that's associated with two different IP addresses, and that's because that ARP packet got sent out. This Windows 7 machine adjusted its ARP table, and now it's routing any traffic to either of those IP addresses to the same MAC address, which is the hacker's computer. Beneath that, we've got a trace route from a Mac OS X Lion machine, and as you can see, it's now routing its traffic through the hacker's machine, 192.168.1.119, instead of the router, and the attacker's machine is forwarding it on to the router. It becomes transparent because the attacker's machine forwards that traffic on, takes the response, and sends that back, so that the victim can never really tell, at least not easily, that he's been victimized. Right, so the project and our motivation. We always get asked, why did you do this? What's your motivation for the project? Don't you know this is a bad thing and you're evil? So, you know, in answering that, I like to start with talking a little about history. A fellow named Doug Song, over 12 years ago, released a toolkit called DSNF. In that toolkit was a program called ARPspoof. And what ARPspoof did was, you know, ARP cache poison the network, make the computer man in the middle, and the point was to demonstrate exactly how vulnerable people on a local area network were, and then hopefully, you know, bring about some kind of fix or at least some kind of awareness. Here we are 12 years later, and your average consumer router still vulnerable to the exact same attack, archaic, nothing special. So we thought we'd go ahead and about it a little bit different of a way. So Subterfuge, it makes it obvious to anybody, no matter how tech savvy or non-tech savvy you are, just how vulnerable on the network you are and exactly what you're getting. So rather than just, oh, somebody's man in the middle, he's seeing my traffic, what does that mean? We actually display, you know, here's what you got, here's something else you got, and, you know, there's a real risk and here's the threat. So hopefully that's going to make consumers demand some kind of protection in their routers. And those protections do exist. Router companies just haven't given them out to consumer level routers. So hopefully when consumers start demanding that, router companies like Belkin and Cisco and what?
Got him. It says Nick here. I don't know what you're talking about. So anyway, about 4 months ago, we took Subterfuge and we decided to put it online. We put it on Google Code, and it was really just to help us code better and, you know, project management side of the house, just keep track of everything. And since we did that, there have been a slowly growing community that have actually stumbled upon our site and our project, and the response has been pretty positive so far. So we've been, you know, continuing to program and keep this project alive. We've already had, you know, thousands of people download the code and our white paper. We've had thousands of people view videos on it, etc. And apparently our wallpaper is even cool enough that hundreds of people have downloaded that. So I'm not quite sure about that. We've also had people from the community contribute small portions of code, volunteer to be hardcore beta testers, and just recently we actually were approached by Backbox Linux because they wanted to include our tool into their security distribution. So now let's actually talk about Subterfuge.
So Subterfuge has a couple improvements over most man-in-the-middle tools you see out there. The first and foremost is that it's got a very intuitive interface that's extremely easy to use. For instance, whenever I'm trying to use Kane, yeah I know right, Kane, Whenever I'm using Kane, I can never find the button to pull up that menu to do that thing I'm trying to do that one time, because it's just busy. Subterfuge is not that. So subterfuge is there to demonstrate the vulnerability, to exploit the vulnerability, and to get what you're trying to get, and no ifs, ands, or buts about it. It's also very point and shoot. There's a start button in the right-hand corner. You click the start button. It asks you if you want it to do everything for you. You hit OK, and you're on. It's also really silent and subversive. Unlike most man-in-the-middle tools where it's spamming ARP, particularly for ARP cache poisoning tools, subterfuge actually has a couple innovations, if you will, that we're going to talk about in a little bit when it comes to poisoning a network that really allow it to be a lot more silent. A couple other things that we've integrated into subterfuge we'll also talk about in just a little bit let us subvert the user and make it really transparent and very hard for the victim to actually realize that they're being exploited. And finally, subterfuge is open source. So if there's this man-in-the-middle tool and you want to do a man-in-the-middle attack, but it's not doing it quite the way you want it to, subterfuge is written in Python. So actually editing that, building a little bit of an addition to it is very simple, very easy, and you can see everything that it does. So let's talk about a little bit about the framework. This is really what makes subterfuge a bit different than most man-in-the-middle attack tools. It's got a servant-client architecture, which means that you can actually collaborate with this. Most of the time when you're having a man-in-the-middle attack, you got one person who can do it, because there can't ever be two men in the middle. That's kind of difficult. If you try that, the network's going to go down, nobody's going to get traffic, and your idea of transparency completely gone, nixed by the fact that you've got two people struggling to be that man in the middle, and the network just can't handle it. So with subterfuge, there's one person who's doing that man in the middle. That's the subterfuge server. And you've got clients who can connect to that server and they can all use it at the same time. We also went ahead and split apart the two pieces of a man in the middle attack. You've got your actual attack, so your exploit on the network, where you get your man in the middle position and then you actually leverage that attack to do something, right? So if we get this position, then what do we do with it? And if you're a developer, you can get the man in the middle position or come up with a new network exploit, and you can integrate that into subterfuge without having to actually build the backbone to do something with that attack every single time you come up with a new attack. We also have a lot of configuration options, which means that if you're coming up with a new attack that really needs to have a little bit of nitpicky man in the middle positioning, you can go ahead and configure and set that all up yourself, and we'll get a little bit more into that in the demo when we actually touch on it.
All right, so I'm going to go through a comparison of just some of the other tools that are used for man-in-the-middle attacks right now, and then we're also going to touch on what's new and different with subterfuge. So other tools, we already touched on it, are spewing out ARP packets all the time. If you're on a network that's being poisoned, you could pull up Wireshark and actually watch the sheer number of ARPs coming through and see, hey, this is probably a man-in-the-middle attack. The other thing is there's some unacceptable periods of MITM loss, where just due to basic traffic, clients will lose that man-in-the-middle position and the attacker will not be able to do anything. And in general, a lot of these tools actually, after running for even a short period of time, can just completely overload the network and make it crash. And that completely goes away from your stealth and transparency, because obviously no internet, they're going to start complaining. So subterfuge, Python, it's open source. That's a pro. The other thing is it also has what we like to call intelligent poisoning and dynamic poison retention. Now, intelligent poisoning is what allows you to change the throttle of how fast the ARP poison packets are coming out. Now, on that threshold, there's only one packet being sent out. So instead of constantly doing ARP scans, seeing who's there, sending out poison packets, or just spamming every single IP address, it's intelligent in that it sends out one packet on a certain threshold, and that's it. Now, dynamic poison retention is really unique to subterfuge, where it actually listens for those basic ARP communications between the router and the clients, or the clients and the router, that would typically make you lose that man-in-the-middle situation. So there's oftentimes Windows, for example, when it first turns on and connects to the internet, even if its ARP cache is full, it'll say, hey router, where are you again? Just checking. Now that would normally make you lose the man-in-the-middle position if you were an attacker, because that communication, the router would say, here I am, and the client would be like, oh, there's the real router. But now subterfuge actually monitors the network, listens for those types of communications, and is instantly right there. So the second that router is sending the response, subterfuge has already sent out a packet and is saying, no, please remind them kindly who the real router is. And then we also have what's called ARP block. When you're in that man-in-the-middle position, we use ARP block to prevent any kind of communication from the router to the client. So it forces all of the clients and now victims to communicate directly through us, and the router can't come in and kind of steal the show. So it just prevents, once it's in that man-in-the-middle position, it kind of, you're in charge, and so we can say, you know, what ARP packets go back and forth.
Right, so something else we actually used as a big backbone component of Subterfuge is SSL Strip. So Moxie Marlinspike at Black Hat in 2009 released SSL Strip, and it runs an HTTPS downgrade attack. So when we first came across SSL Strip and started looking into the code, we almost felt like we died and went to heaven because it's written in Python, for one. For two, it also acts a little bit like an intercepting proxy. So we went ahead and customized it to actually use those features to log basically everything. Because really everything that goes through the network has some kind of use to us as, you know, the man in the middle or the attacker or the penetration tester. So that traffic is now all routed through the intercepting proxy and logged in Subterfuge's database. Now after we log it, well, when it's coming back through, we can pretty much do anything we want to it, right? So we figured here's a great place to start injecting things or modifying traffic on the fly. We do that through something we like to, or through a little bit of a smart injection. So you know, you browse to yahoo.com. That site's freaking ridiculous. You go there and it pulls in 20 external sites every time you go just because it's got so many news articles. Well, if you were just slapping on an injection to every single site that you went to, when somebody browsed to somewhere like yahoo.com, you'd inject that site 20 times. So with smart injection, it knows when that's happening and only inject it once. And it also lets you really control the rapidity of your injection, especially if you're looking for very specific modifications to somebody's browsing session.
Here are some of the plugins that we're going to briefly talk about. We actually have 3 of these up here we have demonstrations of, so I'm going to only talk briefly about them. But the Credential Harvester is the main module or plugin in Subterfuge, and what it does is it uses all the back-end tools, the ARP poisoning tool that we wrote, it uses SSL Strip, puts it all together in one spot, configures it without bothering you or you having to do any kind of text file editing, and just works. And so what happens is you click start and it'll start intercepting any kind of web login traffic. Code injection is actually we're able to intercept the traffic as it's going between the legitimate source and the host, and we're able to slap something on in the end. And we'll talk more about what you can do with that. Now, denial of service for you anonymous types, if you just love everything to do with DOS and you just are so excited. We made one of those too. Denial of service, there's many different uses of it, and an ARP denial of service attack is very effective, as we found in development. There are constantly times where we were developing this, something went wrong, and I had a really fast internet connection and he didn't have any. But denial of service, you know, you could use it for multiple different things. You can just say, I don't want this individual to have internet, or I really need to use all the internet right now. I'm sorry everyone, go sit in the corner because I'm going to use all of it. Yeah. Then another plugin, Tunnel Block, actually is brought up in the development of Subterfuge. A friend of mine, fellow computer scientist, he said, well, even if you have the man in the middle, if I have a VPN or some other kind of tunneling encryption protocol, you're not going to see what I'm doing, right? And I said, well, if I'm man in the middle, I can do whatever I want. So with Tunnel Block, the module, all it does is it blocks the standard protocols and tunneling services on the standard ports. So PPTP, Cisco VPN, L2TP, OpenVPN, SSH, all that stuff, if you want to, you can enable it. So by default, those things will be blocked. So you could even have an intelligent user on a public Wi-Fi saying, I'm going to be secure, I'm going to log into my VPN. When they pull up their VPN, hit connect, because I'm man in the middle, I'm dropping all those packets, so it'll just hang, they'll never connect. And they'll probably be busy, so they're going to continue on their way regardless. And we're also going to actually have a demonstration of network view. It's a really unique feature to Subterfuge. It's a whole new way of visualizing the attack as it's happening. It's a dynamic view that updates and lets you visually see the network as you're attacking and who exactly you're man in the middle. So here is a demonstration of the credential harvesting module. So as you see, when you start up Subterfuge, it's pretty simple. Up in the upper right hand corner, there's a start button. When you click it, it's going to say, hey, do you want us to do all that work for you? And you're going to be like, sure. So it's going to go and get the network adapters, IP addresses, all those things. You're going to be like, okay, cool, that's awesome. So I'm just going to click OK. I click start, now I'm clicking OK. Here it goes. It's off. Now in the background it's using SSL strip, all these other things, and everyone's getting poisoned in the background. Now these people, unfortunate people, you know, Facebook, eBay, Amazon, LinkedIn, they're all visiting the site thinking that they're secure, and here's their plain text password. Now I don't think we could demonstrate an easier way of seeing how vulnerable people are to these attacks than this easy to understand interface. I mean, you got the source, the username, the password, the date and time when it happened, clear text, all right there. You can see just how devastating it is because there's everyone's passwords. And that's kind of one of the big things that we wanted to demonstrate.
We also got the opportunity to just give a little bit of a demonstration of subterfuge at the undergraduate level before coming here. And we just pulled this specific piece up, let those undergraduate students who weren't necessarily computer science majors just get a look at this, see that they could click the start button, click OK, and that everything on the network was pretty much accessible to them. And that really opened their eyes, and it kind of did what we built Subterfuge to do, to make it really obvious, no matter how tech savvy you are or how tech savvy you are not, just how easy it is to get your credentials. And I don't think they'll be doing their banking on Chase anytime soon. Right, so Subterfuge does more than just harvest credentials. We built Subterfuge around credential harvesting specifically because we thought it demonstrated very, very well and very astutely how vulnerable you were every time you did anything online. But Subterfuge is a framework, which means we want it to be able to do just about anything. So here at the plugin menu, if we were to click on Credential Harvester, it just gives a short description on the right-hand side of what the Credential Harvester does. If we click Apply, it'll take us there. In this case, we're going to go ahead and click on HTTP code injection, and look at that. Top right-hand corner gives a short description of what HTTP code injection does. If we check running, it'll make sure that everybody on the network's injected. We got a couple different vectors we can use. Subterfuge is integrated directly with Metasploit, so we can use browser autopwn to inject people if we'd like to, or we can inject them with our own custom special sauce. So if we were to pick Metasploit, we could go down to payload and pick the type of injection that it would do. We could do iframe injection, which is hidden and the user wouldn't actually experience or see, or the victim, excuse me, wouldn't actually experience or see anything. There's also window redirection, and we could also pop up really an exploit in the pop-up. This is really good because not all browsers like it. So if we pick custom injection here, we can go ahead and type in anything that we want slapped onto the bottom of anybody's page. In this case, just to demonstrate, we're going to do a real quick script tag. It's just going to inject an alert that says osmosis was here into the victim's browsing session. It's as simple as just typing out whatever you want to have added and clicking apply, and now it's being injected. So now the next person to who's been man in the middle on the network to browse to anything is going to receive that injection. So here we've got a victim running Windows XP, Lord knows why. Also with the Google Chrome browser, he's just going to browse to google.com, and now he's got our little special sauce, our little nugget of joy. It says the page at google.com says osmosis was here. This is actually a really good way of demonstrating another little tidbit about what makes man-in-the-middle attacks and the man-in-the-middle position so powerful. Because the user sees the page at google.com said this. Because it's coming through us before it reaches them, we can pretty much make anything we can possibly think of look like it came from whatever the source was. So I could send them anything I want to, and they'd think it came from google.com. So this is the network view. This is really what makes Subterfuge a little bit unique. It's a whole new way of interacting with a man-in-the-middle position. Every single person who comes up here, so for instance we just got a client 192.168.1.119 is man-in-the-middle. So that means that all of their traffic is being routed through us. It'll only display the people that we have victimized. And it is also integrated directly with Metasploit. So if you hit the scan button, it'll automatically do a Metasploit, or excuse me, not Metasploit, Nmap. If you hit the scan button, it'll automatically do an Nmap host identification scan and pull in that information and put it to Subterfuge's database. It'll then automatically upload or reload the specific pieces of the page to keep it up to date. So now we can see we've got a Linux box, a Windows box, a Mac OS X box. We can tell also what open ports there are, so we might be able to derive what kind of services they're running. The network view really just gives us a really quick and easy way to see everything that's going on the network, everybody who we've got doing anything on the internet through us. And it also lets us control that. So here we're actually going to interact with HTTP code injection through the network view. If we go ahead and click that and we check the running box, then everybody on the network is now being injected. We're going to go ahead and do this with Metasploit. So we can pick the vector as browser autopwn, and our payload, in this case we're going to go ahead and use iframe injection, simply because iframe injection is just really transparent, works really well. Some browsers don't like it, which is why we have other options, but that's what we'll go ahead and do. Now if we just hit apply, it starts it up. So that runs a Metasploit script, which is run dynamically through Subterfuge. It'll grab your IP address and start injecting that in a hidden iframe into users' browsing sessions. So that started up the Metasploit server, and now there we go. We got somebody who browsed on the internet anywhere, and that's running a payload through Metasploit, trying to exploit into that victim's browser. And we just got a session. In this case, it was a session that was generated on Windows 7 box running the Google Chrome browser. And since Metasploit stays very, very well updated and browser autopwn is run directly through Metasploit, you can also guarantee that this attack is going to stay applicable and that you're going to continue to be using the latest exploits that are in Metasploit's database as long as you update Metasploit. So this really just demonstrates a new way to interact with the man-in-the-middle position, a new way to really control the network and to own peeps. Right, so it's a framework, right? And it does some things now, but what if you came up with your own little network exploit or a plugin to actually do something with that, position? Well, what do, right? You could build your whole own tool that just gets man in the middle, uses man in the middle to do whatever cool thing it is you came up with, and it's got whatever interface you also built for it. But with Subterfuge, you can actually go ahead and build any program you'd like in Python, and you can use the Subterfuge module builder to generate everything else for you. So if it's a network exploit, you can use that, or if it's a way to leverage a man-in-the-middle position, you can just go ahead and go into the GUI, the module builder, and configure it. Subterfuge will automatically generate you all the graphical user interface code that you need, rather than having to do any of that yourself, rather than having to touch nasty JavaScript. And it can be really nasty, especially if you want to have really good graphical user interface interactions that happen, statefully on a stateless protocol. Subterfuge will go ahead and do all of that for you. And finally, we've also got our settings. With a man-in-the-middle attack tool, for the most part, settings are done through configuration files, or at the very least, they tend to be a pain in the rear. And if you do something wrong, everything just doesn't work, and you can bring down the network. And if you're doing a penetration test, that's just unacceptable. You can't really ever bring down some corporation's network when they brought you in just a test to see if it was secure. I mean, then you're worse than the darn hacker. So what Subterfuge allows you to do is really configure and control everything. Anything from refresh rate, so how often Subterfuge will query its database and reload to display to the hacker how new the data is. Which is really important, especially with a server-client architecture. For instance, if you're running old routing equipment that can't really handle too much traffic, and you're collaborating with 10 people at the same time through one Subterfuge server, and you use the default and you're refreshing that every single second, then all of those people are refreshing a whole web page, or not a whole web page, but pieces of a web page every second. And the router's got to handle all that traffic. So if it's an old system, it might not really like it too much. With Subterfuge, you can go ahead and control that. You can dial it up, you can dial it down. Really, the sky's the limit. And the same thing is true of injection rates. So if I'm injecting, say, a Metasploit, a link to Metasploit into a browser, so I'm owning them with Metasploit, well, we had the other talk earlier who had 1,400 shells, something ridiculous. But honestly, if I own somebody's computer, I don't really need to own them every time they browse to a new page. So I can go ahead and dial that down if I want, and then it gives me the chance to get my shell, turn HTTP code injection off, and remain as transparent on the network as possible. It also allows us to control really how the ARP poison works. So through dynamic poison retention, that might mean that we want to dial down, or it means certainly that we can dial down how often we send ARPs on the network without actually losing the poison. So we might want to check that box so that that is running, but dial down how fast it is so that we can stay really stealthy and really silent on the network. With Subterfuge, it's really easy to do.
Okay, so now we talked a lot about Subterfuge, and in the end, we really want the router companies to be fixing this at the consumer, product level. But let's talk about some of the countermeasures and how you can protect yourself in the meantime. I'm just going to go in a quick explanation of a quick fix that I thought of. that I'm calling gateway self-awareness. Now, without that much overhead and additional inspection that routers already do, if the gateway is just self-aware of its own network adapters, like if it knows its own LAN MAC address and its own LAN IP address, that can prevent all of these attacks from happening. Because the router is what sends all the packets around. So if a router gets a packet that says, hey, this is the router's IP address, but that's not my MAC address, it drops the packet, the attack is thwarted. It will never go through. It would be something as simple as that. I mean, there is other protection. There's enterprise level protections, obviously, with DHCP snooping and Cisco Magic. And they can bring that down to the consumer level too, but I think that it should be demanded by the consumers that they be protected from this at public hotspots or, you know, other just consumer routers. But in the meantime, I'm going to go over some of the things that we found through our development. Through our testing and development, we saw that Google Chrome actually tends to be, you know, the most secure in terms of the browsers to use. And one thing that we saw was just the way it organizes how it displays a web page. So with Google Chrome, the favicon is displayed, you know, the favicon of the website is actually displayed on the top of the tab. Now, SSL Strip has this really nasty feature where you can inject a lock icon into someone who's had that HTTPS downgrade attack. So, you know, if you're using any of the other browsers like Safari, Internet Explorer, Firefox, you could be browsing somewhere and that lock will show up, which will be, you know, a further way that people will be like, oh, okay, I'm secure, I'm going to keep going. However, with Chrome, there's a specific icon built into the browser that says, I'm secure or I'm not secure. And that's what's next to the URL, and the favicons on the top. So that's just easy to see. The other thing is, Subterfuge and SSL Strip, it never actually attacks HTTPS, at least right now. It doesn't step in the middle of the encryption or the handshake, because that would set up some certificate errors. It wouldn't be as stealthy and transparent to the users. That's not what we wanted. So if you ever look at the URL bar, it actually will always say HTTP. The only way SSL Strip works is it banks on you saying, I'm going to www.google or facebook.com, not typing https://. If you do that, it's going to connect over TLS SSL, and we don't step in that process, so you're safe that way. But even if you're just browsing, clicking on links, because SSL Strip goes through pages and takes the S out of all the links, if you're just browsing, if you look up and you don't see an S, you're not secure. So always look for that S. Just recently we actually had the idea, and I built a proof of concept program that can actually detect if there's a possible man-in-the-middle attack happening on your network. Now the tool is written for Mac. It's written in Python, and like I said, it's really proof of concept. But what it does is you connect to a network, you run this thing, and it'll sit there, and if there's ever an attacker, it'll pop up and tell you. And all it does is it compares the ARP tables and makes sure there aren't two IP addresses mapping to the same MAC address. It's very simple. And then, like I had mentioned, if you aren't already man in the middle and you can have a VPN or use some kind of encryption and tunneling protocol, that's obviously going to help you too. So those are just a couple of things that you can do to help yourself out.
Excuse me. So we're also looking at future work. Subterfuge is still in beta, and it's a work in progress. Can you do yours too first? Excuse me.
I'm going to skip down to mine. I'm doing collaboration support. One of the big things with Subterfuge that, like we said, it's unique about is that collaboration ability with the server-client architecture. So we really just wanted to work on, you know, the conflict resolution and make it more usable in a collaborative environment. And one idea we were actually given was to have Subterfuge as a payload delivery, you know, for a Metasploit payload or something in the future like that. We talked to Mudge about trying to figure out maybe, you know, future work, but pretty much man-in-the-middle attacks right now, you have to be there on the network in order to do it. So we're thinking about somehow packaging up Subterfuge as a remote deployable tool so that you can own a box on a foreign remote network, have a pivot, deploy a Subterfuge server, and start man-in-the-middling a foreign and remote network without actually having to be there. And we thought that would be pretty devastating in terms of penetration testing and what kind of credentials and other things you can gather remotely.
Right, sorry about that. So we're also looking at Subterfuge as a future project. It's still in beta, and we're really working on what Subterfuge is going to be rather than what it just is right now. And that really includes other mechanisms of gaining a man-in-the-middle position, as well as other ways to use it. For instance, we're looking at as other ways to get a man-in-the-middle position, exploiting DHCP race conditions in order to convince somebody that or convince somebody to go through you as opposed to the router. We're also looking at building a Wi-Fi module. So this would do something kind of like what Karma tends to do, where it would start up an Wi-Fi server, or excuse me, a Wi-Fi access point as Subterfuge. And Subterfuge would go ahead and do this for you. So if we go to, say, the Las Vegas airport over here, we'd see free public Wi-Fi. It's everywhere. And it's always real, always. But aside from that, we'd also probably see Las Vegas, airport Wi-Fi. And everybody who goes there is going to see that, expect it to be open, and then expect to be able to get internet through it. And the amount of people who actually think that it's secure is just absolutely astounding. So Subterfuge would then be able to just set up an access point like this for you. You'd basically type in the name of the access point that you wanted, and people would connect to it. You're not really exploiting anything except for the fact that people just think they're secure when they really should know better. But it's another mechanism gaining man in the middle, and there are really a plethora of other ways to gain that position. Just every day we find more and more and more. And as a framework, we can build that into Subterfuge and still use everything else without having to redo anything. We're also looking at different ways to actually excise said position. For instance, 2 years ago, so I think DEFCON 2010, there was a tool release called Evil Grade, and if you've got a man-in-the-middle position, it'll go ahead and pretend that there are updates for any given application out there. For instance, anybody ever use iTunes? I hate the darn thing. Every time I connect to the internet, it tells me I've got about 20 updates to do. Well, people are used to that, so they're going to click Install Updates. If Subterfuge is man-in-the-middle and an Evil Grade plugin is running, you'd be able to iTunes would go out and it would look for a new update. Evil Grade would say, hey, here's one, and it would automatically give it to you. And that all within Subterfuge's interface, which is really an idea or an example of how extensible Subterfuge tends to be. Because it's really easy to use, but if you come up with a new attack, all you have to do is integrate it into Subterfuge, and everything else is there. You can use the GUI, you can use the mechanisms of gaining man in the middle, and you can use really everything else. We're also looking at OS compatibility. Because Subterfuge is really supposed to be a tool that spreads awareness about how bad the threat and the risk of somebody being man in the middle to you is, we're trying to port Subterfuge to other operating systems. Mac OS X is probably going to be our next one, and then Windows XP followed by 7, which will both be a nightmare. But the point is, we'll be able to extend it and port it to different applications so that consumers of routers who really don't necessarily know how vulnerable they are will have the ability to really see it everywhere, or even pull it down themselves before they go out and buy a router and really realize how bad things really can be. Yep.
So in summary, so far we've learned that apparently my co-developer thinks that Hummer makes routers. Besides that, we talked a little bit about man-in-the-middle attacks, just our framework, getting versus leveraging our position, and just that split. We had a couple demonstrations and talked about the countermeasures to keep yourself safe in the meantime, and we also talked about our future work. So here's a link to our site where you can get the code. We just wanted to thank you guys all again for coming to our talk. If you have any questions, suggestions, we'll be in the question room. Thank you very much.